Okay, guys. So I want to talk about a couple of the Maclaurin series. Specifically, there's one that we haven't mentioned before. These other three we've talked about. We've talked about e to the x, we've talked about sine x, and we've talked about cosine x. And if you don't already have these three memorized, you really, really should. Um, right? We have e to the x, right? 1 plus x squared over 2 factorial plus x to the cubed over 3 factorial plus yada, 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 right? And this is that summation of n equals 0 to infinity of x to the n over n factorial, right? And then we have sine x, which is x minus x cubed over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial plus so on and so forth. And this is the summation n equals 0 to infinity of negative 1 to the n, x to the, that's an x to the 2n plus 1 all over 2n plus 1 factorial. And then cosine x. And if you can't remember cosine x, as long as you get sine x, you can take the derivative of that and you get cosine x, right? And for this one, we've got summation n equals 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. Okay. Now, there's one that we haven't talked about, and I mentioned it briefly, and that one is 1 over 1 minus x. Okay. So I want to take a couple minutes, and I want to go over this one with you real quick. Okay. So 1 over 1 minus x is another Maclaurin series that you should know and you should be aware of. And so we're going to discover this one real quick. Okay, so 1 divided by 1 minus x. So let's do that. Let's do 1 minus x divide into 1. Okay, so 1 minus x divide into 1. So how many times does 1 go into 1, right? Well, it goes in one time. Okay, so now we're going to distribute. We're going to take the 1 and distribute it out. And what do we get? We get, well, 1 goes into 1, well, one time. 1 goes into minus x times. Subtract it out. What do we get? 1 minus 1 is, well, that's 0. 1 minus a minus x, and that leaves us with an x. Okay, so plus x. And so now we got to ask the next question. Actually, I should probably erase that and ask the next question. How many times does 1 go into x, right? How many times does 1 go into an x? Well, it goes into x times, so plus x. And so what do we get? We multiply again. We distribute this x out into this, and x times 1 is, well, x. X times a minus x becomes a minus x squared. And again, we're going to subtract this out. X minus x is 0. Minus and minus x squared is going to become a positive x. And so now the question becomes, well, how many times does 1 go into x squared? And it goes in, well, x squared times. So again, we're going to take this and we're going to distribute that out. And x squared times 1, well, that's x squared. X squared minus an x is minus an x cubed. Subtract that out. And then we're left with a positive x cubed. And I think you can kind of see where this is going to go. We're going to get x cubed plus dot, 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 so on and so forth, right? You see this pattern, 1 plus x squared plus x cubed plus so on and so forth, okay? And so what this actually ends up becoming is this summation right here, where n equals 0 to infinity of x to the n, okay? What does this look like? Well, looking at this right here, this looks like a geometric series. And in fact, this is a geometric series, okay? And this is going to converge at very specific points, right? This is going to converge when we have a ratio that keeps that value under 1, right? So if I have a ratio, my ratio is x, right? My ratio is going to be x. So it's the absolute value of x. As long as I keep that under 1, it's going to converge, right? So if x minus 0 is less than 1, it's going to converge. And so therefore, this geometric series converges when x exists within a very specific point. Well, where does it exist in less than 1? Well, that's only going to happen when x is in the small little space between the numbers -1 and 1, right? Those absolute values of -1 and 1 creates a small window, right? If I'm at 0.9999999, that's less than 1, it's going to converge. If it's at 1, it's not going to converge, right? That's our geometric series rules. So again, another special Maclaurin series that you should be aware of is that 1 over 1 minus x, it's a geometric series, right? We know that one. We've seen this. If this is my a sub n term, this becomes r, right? This is a sub n, and this is r. We can evaluate when it converges, and not only that, we can evaluate what it converges to. And so in this particular case, my geometric series, as long as this stays within that interval between -1 and 1, can't be -1, it can't be 1, so those ones diverge. But if it's within those, it's going to converge. Okay, so again, this is just one of those Maclaurin series that you need to be aware of. So in addition to sine x, cosine x, e to the x, this is another one that we get to add to the little bag of ones to be aware of, 1 over 1 minus x. 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus so on and so forth, which is just the summation of n equals 0 to infinity of x to the n.